fixed it. I'm really curious. Okay, seems like it's working now fine. That was very strange. I really don't know what happened there. I didn't really change anything, I just restarted OBS and Tidal that's running on the background. And it seems fine now, so let's hope it stays fine. Yeah, I mean, I will need to like double check if the sound is okay from time to time, I guess. But really no clue what the heck happened there. Sorry about that. Okay. So where were we? Okay, right. I wanted to just do that. Let's see if that accidentally breaks anything. Hopefully not. Okay, cool. It does seem that everything is working now. Well, that was annoying. Okay. Right, so where were we? We were talking about the chains, right? Yeah, okay. Cool. So let's get back into the chains. Hopefully no more technical issues for me today. Especially since I don't know what the heck actually happened. Right. So yeah, I was talking about remote pairs that are kind of the simplest form of this. Yeah, this is a little bit more of a complicated picture, but it's the same idea. So if you pick an 8 here, that forces a 2 to where actually? Yes, to here. That forces an 8 to here, forces a 2 to here, forces an 8 to here, forces a 2 to here, forces an 8 to here, forces a 2 to here, and vice versa. So there's always an 8 or 2 for basically this row and this block, which eliminates these two, and for this row and this block, which eliminates these two. This one is eliminated because it sees this one, I think. Yeah, I think that's actually it. Okay, so let's write down what we actually need to do. So we need to build a graph where the nodes are number possibilities So basically, for a particular number, it's, you know, it can be present in a particular position in the grid. That's kind of what we are interested in. And yes, if you're watching, please do let me know if the sound is okay now. I don't know what the heck that was. And the edges are either weak links, which means if we pick this possibility, which other possibilities are eliminated, and strong links if we don't pick a possibility, this possibility, which other possibilities are forced. So yeah, if we basically say this is not an option, what are the possibilities that are straight up forced to be set? So we need to build this. Once we build this, we can then run searches on top of this. And look for our chains. Okay, let me just double check the stream if everything is fine. Because now I'm like super paranoid about this. Right. Okay, yeah, hopefully everything is okay. Technology. I've been having so many troubles with my computers and with the software, it's kind of insane. And the weirdest thing is I actually did test this and the recording was fine. It's just that the live stream somehow completely freaked out. Okay. So where do we build this? So this graph is global for the puzzle. So this should be some sort of method on the Sudoku class. Now, what would be the best way to like represent this? So I think this we just want to represent with coordinates like x, y. And the question is, how do we represent the edges? Kind of the easiest way usually is just to have like a grid of everything to everything. But the problem is that grows pretty fast, so it's like, you know, for a 9 by 9 Sudoku, that's 9 to the 4. For 16 by 16, that's 16 to the 4, which, you know, 16 squared, yeah, that's quite a lot of possibilities already. I mean, this would be just bits, but you know, this is 8 kilobytes of data. And we probably, like, the chains we kind of want to do pretty late in the puzzle. So the number of edges and the number of actual possibilities we care about should be reasonably low at that point. Yeah. So I'm leaning towards like a sparse data structure for this. I could just have like a set of pair of xy, right? And I just, you know, ask, I guess unaltered. I just ask, you know, does these two have an edge? Yeah, it should be pretty reasonable. The only tricky part here is I need to, because the edges are symmetric, so I need to insert both of them. Or when I'm doing the lookup, I need to kind of double lookup. Like, I think it's easier to just insert both. Yeah. And I'm wondering if we can, it's probably not a great way to update this based on how our solver actually works. I mean, in theory, this should be pretty easy to update, right? Like, if I remove a possibility, all that happens is I remove the node and I remove all the edges from or to that node. But the problem is the way we kind of invoke the different solving techniques is just like we just do something to the puzzle, and then at some point later we just call, hey, have a look, essentially. So we could do it, but that would basically mean we would have to figure out again what changed from the last iteration, and then based on that go back and try to remove the possibilities or not. Okay. Yeah, I think I will just regenerate this every time. So basically, we have a method. Okay, let's try start coding actually something about this. Okay, so we will have some sort of class that will be the chains graph. And we want to get that from the puzzle. Right. So somewhere in the solver we just call, you know, generate the graph. And then based on top of the graph, we can trigger the different solving techniques. Yeah, I think that makes sense. So we said that this thing, right. So this thing, oops. It will have the nodes. So I guess this will be just a vector. I mean, actually, we don't really. we need might not even need the nodes, but I guess let's just it will be unsigned because that's what we are using. Yeah, I might not need this, but well, let's see. Then I want the two sets, so unordered set. Oh, I just realized this might not work because I don't remember if it's overloaded for set. If you have a hash function for set, damn it, not for set, for pairs. I don't remember that, unfortunately, but we will see soon. So we'll have the weak links and we will have the strong links, right? So this will be the nodes, weak links, strong links, right? And I guess to just see if this compiles, we can quickly do build, rebuild. Okay, seems to compile, although since we are not really using it, that doesn't really tell me much. I guess I can just quickly do return chains graph. Hey, return chains graph. Is it a little low? Okay, I just had a stream restart basically. So do you mean the music is a little bit too low or my voice is a little bit too low? Yeah, we don't have a hash for pair. It's annoying. Well, I guess then we just use a set. And yeah, I think I will need to provide a comparator. Yes, include set. Okay. So this actually compiled. Now I'm a little bit confused because this is weird. Like they should still complain that there is no comparator for pair. Or does pair actually have a defined comparator? Okay, that's interesting. Oh yeah, there's actually, wow. These are removed in C++. Oh, because they added the new comparator thingy. Okay. No, that's convenient. I actually didn't know about that. So this I guess is fine at that point. Well, I guess then we just need to write this method. Yes, I know. The tricky part is you are actually not supposed to provide overloads and specializations for STD data structures. So technically, like writing your own. Although, can you do that just from the as a parameter? Let me quickly check. But yes, you definitely need to provide your own. Oh no, okay, so you can put it in as a template parameter. Okay, is there a quick way to do that? No, okay, that map is fine. Okay, so like this. That doesn't look too crazy. And wait a second. Ah yeah, here we pass it as a template parameter. Sure, what's happening? Oh, this modern websites, like you have a 10-second look and suddenly it asks you to like give up your soul. Right. Let's borrow this idea then. So we just need to add these things. I think I'm missing. No, is it okay? And what was the? What's this bool over here? So it's a key hash. Why would? Oh, because this is a map, right? Oh yeah, that's a map. Okay, cool. No, makes sense. So I don't need that. So this is indeed correct, and this needs to be unordered set. Okay, build, rebuild. Cool. Okay, now it works. Right, so let's go back to the getChains method that actually builds the chains. And if you are still around Blazor or Blazar, or how do you pronounce your name, please do let me know if the audio that is low is my voice or if it's the background music that's low. Because I can fix it, but I kind of need to know which part needs to be fixing, basically. Right. Around here. Then this can go away. That's way around. Build strong quick link graph of number possibilities. Okay. Right. So what we want to do, actually, I think I did this wrong, because we would basically get this for this is for one number, because these are the positions of the number, which are the nodes, and these are the links. I guess that's okay, actually, because what I can just do is just make it, for a specific number, and then when we are solving the actual chains, I can just, iterate over all the numbers, and that's fine. Okay. Let's see what my phone is doing. Okay. Right. So well, I will definitely need to iterate over all the elements of the puzzle. Yeah. Well, I guess just copy paste this. So if the number is a possibility, no, is it date? What's the name of the attribute? Right. Data, indeed. So, oh, this won't be. Actually, I don't even need that. So we just size, because we are inside of the class. Is possible number. So we want to insert it as a node. Yes. So here we will do an insert node. Now the tricky part is it might be. Oh shoot, I just remembered that I need to actually update the links because this is a new stream and okay, give me a second. I need to do this. Oh, stupid technical issues. Like why would this happen to me? Okay. Right. Okay. Okay, that's that, and I also need to update it over here. Oops. Can I edit this? Yeah, probably not. Never mind. And the last place. The places here. Okay. Yeah, sorry for that, but I totally forgot that since I restarted the stream, like all the links are different now, which is so annoying. Where's the tab? Right. Okay, that should be it. I hope. Okay. Right. Okay, so we first insert the nodes, and I think what we want to do then is actually go over the blocks, and basically to have a strong link between two numbers, sorry, not two numbers, but like two positions of a number, this needs to be like, those need to be the only two places for that number in that block. Yes, so basically for, okay, so something like if number of instances is 2, then we insert a strong link, and if number of instances is bigger than 2, like if there is only 1, there's no link because there's nothing to link to. If the number of instances is greater than 2, then we insert weak links. Yeah, that should work, I think. And since we do it for all the blocks, I mean, there might be some duplicates, right? But the thing is, it's enough for... Okay, so let's go back to the drawing board, right? So yeah, let's imagine this kind of situation. Oops, no, that's not... Okay. So if I have this kind of situation, in this row, I want to have weak links between these 5s. But since these two 5s are the only two 5s in this square, well, these two 5s need to have a strong link also. So basically what happens as I'm going through all the possible blocks, right? Like I go through the rows, I go through the columns, then I go through the squares. Well, when I process this row, I just add the weak links. When I'm processing this square, well, then I add a weak link that already exists because I already processed this row between these two 5s, but also I add a strong link between these two 5s. Yeah, I think that works. Yes, that should be fine. Okay. So the blocks I have in block mapping, yes. No, not block mapping. In here, yes, in checks. Okay, so then I go over checks. Yeah, and I cannot. Actually, it's okay if I do it by like this. So then this can give me the number positions, but also okay, I think we need to do it like that. So if the positions of the number, and the number we are interested in is obviously number. So if I have only two possibilities, else if I have more than two. So if I have only two possibilities, but okay, the problem is this is telling me the positions of the number within this block, but what I'm actually interested in yeah, the problem is what I'm actually interested in is actually the absolute position of the number. Which gets tricky because this is information I don't really store so far, I don't think. Yeah, these are all relative positions within this block. Do I perhaps... Yeah, I don't actually... This will be interesting. I think I will need to rewrite this piece of code quite a bit, because what it kind of boils down to is I just have a pointer to square in the block, which makes total sense, except except not in this case. Well, okay, so the good thing is I can kind of reverse engineer what the square is, because here I'm actually inside of the Sudoku class, which has the array of the squares. So if I just, compare against the beginning of the array, I know what square I'm talking about. But that would actually mean that, well, I either need get square at like a relative position on the block. I guess that would be like the least intrusive way to do it. So basically, if I can ask the block to give me the square that it refers to at the particular position, then I can just go back into my data array and essentially just compare it and say, oh yes, this actually is this particular square. And I just realized this actually wait a second. Oh wait, I still have this as a double vector. Oh yes, because I think I changed this actually, but I reverted the change. Damn it. If I go to my GitHub, right, commits. No, that's not what I want. Where's how do I see like commit log? I guess this, yes. Okay. Yes, I think one of these actually inverted the system size. Don't think it's this one. Is it actually new? Yeah, I don't even notice these things anymore. Everything keeps changing all the time. But welcome to the stream. Yeah. Where the heck did I change? I'm pretty sure I made this change already once. Yeah, okay, so here it is. Okay. Right. So to actually do that, I need to kind of reintroduce this change where all the squares are actually stored in a single array, because otherwise I cannot reason about the relative positions in memory unless I have them in a single block. Yeah, I think that's required for what I'm doing right now. So okay, let's do that quickly. If I remember correctly, this was a pretty small change. So okay, that's one change. Just making this a single. Why am I actually using this? This is such a useless type dev. I mean, it doesn't really save much. Yeah, let's just make it proper vector. Okay. Then I can get rid of this. So now if I try to build, there will be a bunch of errors because now it's a single dimensional array. Okay. So what we want to access is I times size plus j. And the same thing goes here. And we'll just keep repeating the same idea all over the place. Right. So when I'm getting a row, instead of this, I want something like this. And actually the address of that, I don't really need the data then. Okay. So we get the element that's the first element of the row and get its address. And the same goes over there. Okay. Right. So now this needs to change like that. And this needs to be size times size. This should work now. Ah, yes. Oh, I wrote it in the wrong way. Damn it. So I want to have a vector of size times size squares. Okay, like that. Oh. What's with today? Today is a weird day. My computer keeps exploding. I keep making weird mistakes. Like this, right? So size, so this is the vector, so size times size of the squares. Yeah. And okay, the move here is fine. Then that's okay, this is wrong. So yes, okay, so now this becomes different because we are missing the information about this. Actually isn't even used, is it? Yeah, let's just get rid of this. Okay. Okay. This will be just arithmetic for accessing to the array. Okay. Oops, no, that was a little bit too much. Okay, here, 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 this one. I mean graph in the mathematical sense, as in nodes and edges. Okay. Oh, to get rid of this. So just a quick recap for this. Basically, what I'm doing and this was kind of lost at the beginning of the stream because of technical issues. My solver for Sudoku can do basically, I have this big data set of like 9 million Sudokus, and out of that it can solve like 98.5% ish. And the method that kind of is missing in the solver right now is chains. So what you basically do, you build this relationship between like possibilities of a number where the number can go in the grid, and some of the edges are strong, some of the edges are weak. The strong edges basically say, okay, if I place the 7 here, it cannot be here. If I don't place the 7 here, this 7 has to be, like this place has to be a 7. So that's a strong link. So it's like both not putting the number there and putting the number there gives you information about the other side of the edge. Weak links only give you information if you choose to put the number there. So if I put the 7 here, the 7 cannot be here. But if I don't put the 7 here, there's the 7 also here in this square, so it can be in either those two places. So it doesn't tell you, which one of these becomes the 7. So it's only on the like, if I put the 7 here, then it tells me something about this node. And you kind of build these, big chains of places where the number can go, which then allows you to remove, like, for example, in this case, this 7, because if you kind of read this chain of possibilities, it's if I put a 7 here, then the 7 cannot, sorry, other way around. I always read it the wrong way. So if I don't put a 7 here, this has to be a 7, which means this cannot be a 7, which means this has to be a 7, which means this cannot be a 7, which means this has to be a 7. So basically, if you don't put a 7 here, this has to be a 7. If I go the other way around, if I don't put a 7 here, this has to be a 7, this cannot be a 7, this has to be a 7, cannot be a 7, has to be a 7. So it's basically, if I put a 7 here, sorry, if I don't put a 7 here, this has to be a 7. If I don't put a 7 here, this has to be a 7. Since this one shares a row with this one and a column with this one, in either cases, basically it eliminates this 7 as a possibility. So that's kind of what the entire idea of this technique is. Like, you kind of build this chain of things where the chain alternates between the weak and strong links, and then you can kind of reason about other places. Like this other picture is basically a more stronger variant of this, where you're actually removing a bunch of different possibilities. So all of these trees will be removed, and it's kind of the same idea. So what I'm doing right now is I'm trying to build basically this graph that tells me, okay, like there's a strong link between this 7 and this 7, and a weak link between these two 7s. Basically have a representation in my code of this data structure. Yeah, Sudoku is fun. Right. What was this complaint over here? Oh yeah, because I'm supposed to return stuff. Let's just fix that. I want to get this code into a place where it compiles again. Not this result. Okay. Okay, so that compiles, but let's just rebuild. Okay, I think we are fine. Let me just quickly rerun all the tests. I hope I didn't break anything. I don't think I should be able to break anything with doing this kind of change. Okay, yes, everything is fine. Okay, so now that we have made the puzzle one-dimensional, now I can rely on the fact that these pointers are sequential. So in these get chains, what I basically want to do is something like get square at the position. Yeah, okay, so this is the unordered set. Not exactly like this, but this is kind of the idea. I mean, iterate over all the positions. Yeah, something like iterate over all the positions and then just get the square at position, and from that we can figure out the actual position in the grid. So then I need to go to the block checker and add this method. So this would be something like, yeah, I have all these type defs that are so useless at this point. I don't really remember why I actually added these. Yeah, let's just make it not use type defs so it's not confusing. Yep. Okay, that should be it, right? I think. Let's just double check. No, it's not all of them. There's more. Okay. Yeah, okay, now it's all instances. So then what I wanted was just very simple, and actually I'm in the namespace Sudoku, so let's just do this, and I should get rid of these. Add a position, return elements position, right? Now the question is if this one okay, so these are zero based. Okay, good. So that's fine. I don't have to change anything here. I mean, that should be actually it. Right? Yeah, I think so. And I can keep getting rid of these. Okay. Right. Well, okay, so if I have two of them, I don't really need to iterate over them because that's kind of silly. Okay, so I can just directly grab both of them out of the. Oh no, because this is just the position. I need to call the get square on top of this. Yes. Okay. Wait a second. Oh, damn it, unordered set doesn't have a reverse iterator. That's annoying. It's a forward iterator. Oh shoot. Yeah, only begin and end. Well, this will be slightly awkward, but this should work. No? What are you complaining about? This next bit. What the heck? Okay, fine. This should definitely work. Yes, okay. So annoying. Right, so if I have the two squares, I need to figure out their absolute positions in the grid. Right, so I will have fx, fy, and then sx, sy. I mean, technically, well, since I just changed the puzzle to be one-dimensional, I could just use the offset in the array, and I mean that would work fine, I guess. Yeah, let's not be lazy. Let's just do it properly. So okay. So fx will be first minus theta 0 divided by size. Okay, so this is the distance of the first node from the first element of the array divided by size. Right. Then fy will be similarly, but not divided, but just modulo. So this will give me the column. And then I do the exact same thing for the second one. Okay. So now I have the coordinates of both of them. So now I want to yeah, okay, so I made this private, but I didn't actually add some methods to like insert stuff in there. Actually, let's just make it a struct. Like, I don't really need to overthink this. This can definitely just be a simple structure that works. Right, so then result dot strong links insert make pair wait a second. This should actually be a pair of pairs, not because a single pair is just coordinate of one number. Yeah. Yeah. Oops, not like that. Okay, so this will give me two coordinates, right? Okay. Yeah, the formatting is a little bit wonky for whatever reason, but that's fine. I mean, considering I just went back from a class to a struct, I'm kind of leaning the way of pairs right now because I kind of want to not have any extra stuff. But in general, definitely structs over pairs, for sure. Kind of like in this case, like this is really just a very trivial data structure. So yeah. I mean, I honestly didn't even have to do that. Like, as I was saying, like since I actually know like the absolute offsets, so this is basically the absolute offset, the first minus, you know, the pointer to the first element. I could just have pair of absolute offsets and not think about it. Because actually I might need to basically, like when I'm actually using this data structure, I might actually need to go back and figure out, oh, like what's the actual absolute offset of this element. Okay. So this is the first pair. Second pair. Yep. So okay, we insert a strong link, but we also need to insert a weak link because again, if you have a strong link, that also implies a weak link. Okay. And this will be slightly more complicated. So if you have multiple, we are not inserting any strong links, but we need to insert a weak link in between every pair, basically. Actually, with like modern C++, let's see. Let me just quickly test this. If I just do result strong links insert, I think this should actually compile. No? Oh shoot, now this one is complaining about stuff. But this is weird, like, they should work. Could not... I need to fix these conversions, but what exactly is it complaining about here? Could not convert a brace and close initializer list. This is a weird complaint. Yeah. I mean, for all intents and purposes, this should be working fine. I think it just has an issue seeing, because this basically gets called recursively. It just has an issue seeing through the recursion. But why? Because this is calling hash, not hash pair. Right. Okay, I think I need to do something like pair. Oh shoot, this is getting unnecessarily complicated. I think if I just... Yeah, screw it. Okay. I will not be overthinking this. Let's just go back to the simple idea. So I will actually store the offsets instead of the XY coordinates. That way I just have one pair, I don't have to overthink it. Right. Okay. Okay. So this simplifies this. I don't need this at all. So what I just want to do is insert two numbers, and the two numbers will be this one and this one. And I guess the same for the weak links. Oh, but actually, okay, I need to do it twice because the relations are symmetric, so I also need to do the other way around. Okay, this should be now finally fine. Nothing should be complaining. Okay, right. So now we are storing the offsets instead of the XY coordinates. So if I have multiple possibilities, basically I want kind of to try all pairs, so it will be for actually not like this. Yeah, well, almost. Okay, so one iterator, second iterator, and we want to check if I equals j, just continue. Okay. So this will also deal with the symmetric nature, because since we go over all the elements in both of the loops, we will get to see the pairs from both sides. So what I just need to do here is something like that and something like that. So square first will be I, and j. Right, and these are actually, so these are not iterators, these are actually the squares. No, these are the positions. Yeah, okay, that's fine. So these are the unsigned positions. Yeah, that works. For a second, and then we just insert this, and that's fine. Okay, so this builds the links. And I think this is all of the code to just build the links. Now, I'm wondering if I actually need... Do I need the nodes at all? Maybe I don't. But then I would have to keep asking if a number is possible. Okay, yeah, sure. Let's do it. Do it like that. That's fine. So because now I have the offset, so let's just keep it the same. So this will be also an offset. And what I want to do with that, where did it go? Okay. Result dot nodes not insert pushback, and what I want to insert is actually this. Okay. Spilling water. Okay. So this will build the graph. We have done that. And I guess let's just, yeah, okay, this is all correct. So now I actually need, yeah, now I need the actual logic that will go over this and try to find the chains. Which should be, of course, the hard part, because yes. Well. So okay, let's go. I kind of talked about this in the screwed up technical stream. So if we have already built up this kind of graph, right? There are basically two ways we can kind of trigger the search. So I can start from a node and basically ask the question, okay, like if I build a chain, and let's just say we are doing this one specifically because there's a bunch of other chains that you can also build. So for this specific thing, we are just building a chain that's length of 4, and the strong and weak links interleave between, in the chain. So it's always a strong link, weak link, strong link, weak link, strong link. So I can kind of go over all the nodes because I do have all the places for a specific number already stored in the nodes. So I can just, given each of these nodes, can I build a chain from this node? And technically there can be a bunch of different chains, right? So basically iterate over all the possible chains starting in this node. And then for each of the ends of the chain, look for a number that basically sees both of these. So, and sees both of these means that there's a block shared between the end of the chain and the number, and there's a block shared between the start of the chain and the number. That's one way to do it. The second way to do it, and yeah, this might be the best way to do it, because once we have built the chain, we basically look for the intersection of the number, like of the squares that these two spaces kind of see, as in, in this case, actually, it's yeah, okay, let me just go to the not there to actually, did I close it? I think I closed it. Right, okay, so let's imagine, yeah, center, okay. So let's imagine we are talking about this and this, for example, right? A bad example. Okay, let's say we are talking about these two. So what are the positions that can be seen from both of these, right? So, well, first of all, these. And that's, is that actually it? Yes, that actually is it. Because it's the intersection of this column and this block. This row doesn't really matter because that's already contained within this intersection. Could we have something more complicated than this? I guess it wouldn't really matter, right? That's, yeah, we are just looking for the intersection. That's all. Like, there isn't anything more to it. Okay. Okay. But before I write it, I really need a short break. Hopefully nothing will break completely once I switch the screens. I do sincerely hope, but let's see. I will definitely recheck once I'm back. Okay, I'm back, and let me just quickly double check if everything is still okay and if the voice isn't breaking up as last time. Okay, everything seems to be fine this time. Okay, so we have the graph, we have built the graph, which is great. Now, so this is basically done. So now we need to let's just implement this first chain thing. So X chain. So we are trying to find chains of length 4, and by length 4, oh no, wait a second. It doesn't have to be a length 4. Length 4 are specifically yeah, so these small ones are length 4. Okay, but this actually can be longer. Oh, and I guess the smallest one we can actually build is length 4, right? Because we need to have a strong link, a weak link, and a strong link, which means we have 4 nodes. Okay. But then it can extend to like whatever. So I guess what we want to do, I mean, I can either just do like a simple depth first or breadth first, but in this case, I'm actually not sure which one is better. I mean, I definitely want to trigger the algorithm for like all valid ends. And this also gets more complicated because I actually might visit the node. So in one particular chain, I can not revisit the same node. But when I'm building the graph, I need to keep in mind that I can reach a node through different means, but that's actually okay. It doesn't really matter that I have like 2 edges here, it's just that if it slots into a place where the weak link is required, it just has a weak link. Yeah, that's okay. Okay. Yeah, I think the depth first search might be more understandable if I just write it like that. I'm just worried that this actually will be like, I need to be really careful when exactly do I trigger this search, because if I do it on a puzzle that has like many possibilities, I think this can just explode, because like if the 7 can be anywhere, well, although maybe not, because I still need the strong links, and I will not have strong links if the 7 can be everywhere, right? Like having a strong link actually means that there's like a row or a column or a block that only has 2 of the 7 places. So it already tells me that like the other 7, like other why am I showing it on a 7? Anyway, well, 9 minus 2 places are not 7, to make it more explicit. Okay. Yeah, I think like just doing a depth first search might be good. Yes. Okay, let's do it. So where do I put this? I think I should just put it into the smart solver. Because this isn't really related to anything, I guess. I'm just doing the search on top of... Yeah, I'm just doing the search on top of the graph. Okay. Let's change, right. Question is where exactly will I slot it then, but well, let's just make it working. So I almost... Yeah, I kind of do want to make it a separate class. Yeah, let's just call it chain finder, and yes, let's add it into the Sudoku lib. That's fine. Okay, so what will be the signature of this? I guess a number and a Sudoku puzzle. Which is slightly awkward, I think, because I think that we actually create like a loop in our headers. Okay, in that case I might not do that. If I just add it into Sudoku, that would also be fine. Okay, yeah, let's just do that. That's okay. And I need to update the CMake list, don't I? Yep. Okay. No, it's fine. Let's just put it here. So next to our other solve methods, which was for a given number. Okay. Now, I actually wonder, maybe we actually want to have it for a given length and a number. Yeah, let's see, maybe this will be better, because I mean, if I just do it, like if I have a method that does basically a depth first search, like a bounded depth first search that only goes, you know, so deep. Well, then obviously, if I call it iteratively with like longer and longer chains, that's less efficient than if I just call it once and it just does everything. But this gives us the flexibility of being able to try to solve like for-length chains, and if that improves the situation, go to like simpler methods that might actually correct the puzzle. And if they didn't, then we can ramp up, and that like those should be progressively rarer and rarer. So yeah, hopefully that works. Yes, solve X chains. Not size but length for a given number, right? Okay, so first of all, we want to get the graph, get chains. So this will be unsigned length. Okay, and I cannot spell as usual. And this we want to get for a number, right? Yeah, maybe this we want to cache somehow, maybe, but let's see. Let's just make it working and then think about optimizing this later. So, as I said, I want to do a depth first search, alternating strong, weak link, and with a strong link. Right. And the length needs to be even because of that. Right. So how do we do this? We want to, we can definitely write it recursively. That's quite reasonably easy. Okay, I could write basically a function that takes the graph, takes the chain graph, takes a function, yes, so this will be not like that, like this, S3 function. So takes a function that just takes as a parameter what just happened there? What the heck? Okay, very strange. So the callback will take as a parameter the number. No, the number we don't need. We need the two offsets that are the ends of the chain. Yes. And the thing is, what this function will actually do it will basically look at these two offsets as in these two squares, and it will do the pruning process. So basically it will look at this 7 and this 7 in this case and figure out that this 7 needs to be removed. That's what I want from the function, from the callback. Because then what I can do in the depth first search, I just, you know, iterate over everything, and the moment I have the two ends, every time I just do, I just call this callback. Okay. So for a depth first search, what do I need? I need the current path, which should just be a vector of nodes visited. And I think I will need okay, this is quite curious. And we also need like a visited list, which technically is the same thing as the path. The problem is, I wonder what's actually faster. It might be fast to just go over the path and see if the given node is already there. Because the path will be generally pretty short. Oh, and it's actually okay. So this is the. I need to have a length of the path that I'm interested in. As one of the parameters to this function. Right. Yeah, maybe I don't need this one. So, okay. So I definitely want to just start with, like, for every possible node as a start. So this will be node of g.nodes. I want to call the traverse again. I actually don't need to make it recursively. Do I, right? Because in every case, okay, let's just ignore the first step. So, okay, so when I'm doing the depth first search, I'm on a particular node. I want to go over all its neighbors And once I have done that, I want to remove the node from the path. But it's kind of, yeah, let's do it recursively. That will be easier. So, okay. If we are getting called oh, we always, okay, so this will always be there. Right. So the terminal case, if path equals path.size equals length, what I want to do is call the function with path 0 and path size, oops, size -1. So those are the two ends of the chain, and just return. So if I'm not in a terminal case, I look at the last element of the path. So and try to find try to find connections to other nodes, but okay, so actually what I want in the graph, I don't want to have a set because that's silly. Then what I actually want is to have a multi-map. Yes, I want to have a multi-map because I just want to iterate over all the edges where the node that go out of this node. And I will definitely need a bool weak here because this basically tells me which of the data structures I need to look into to find the edges. Okay. So back to the graph. So the graph needs to be an unordered multi-map. I guess then I don't need of just a unsigned to unsigned. I don't need any special hashes at that point. Yes, come on. Okay. But this of course changes. So in a multi-map you can actually have multiple elements beneath one key. So in a normal map, if you just, set, okay, let's just jump to the code because that's what I will be doing now anyway. Just a sec. I can show you quickly. This needs to go away. Yes, here. Okay. So basically, if I have a map, right, and it doesn't matter if it's unordered or ordered, that's kind of irrelevant. But let's say I have this, right? So if I do x1 equals 3 and then x1 equals 4, these 4 will basically overwrite the 1 here. In a multi-map, you can have multiple instances of a key to a value. So that's great, like, I mean, for a graph that has, you know, edges going out of a node. If the node is the key, then you can basically store the edges, like the ends of the edges in the multi-map. But they all start in the same key. So this actually doesn't need to change, I think, because we are inserting a pair which works. Yeah, okay, so I was a little bit lucky by writing this code in a little bit particular way, so now it actually even works for the map. I don't have to change anything. Yay! But what I will need to do then is in the actual search, right? So this is my node. Then what I want to do is, and there's a special method to, yeah. I mean, it happens from time to time where you kind of want to have a bunch of different things for a particular key. Like, just imagine that you want to, like, you have a shop and you want to have a list of orders of one particular customer. Like, you can just have it as a, okay, like this, like a list, you can have like a database of orders, and in the order you just say this order belongs to that customer. But that kind of means that if you want to grab like all the orders of one customer, you need to basically do like a linear search for the data structures, right? Like you need to actually go and find all the instances where the customer ID, you know, matches. Or you can have a multi-map where you just go customer order, and, you know, for one customer you just have a bunch of them. I mean, technically you could also do it like if you had a map of the like customer ID to a vector of orders. That also works. And which one of these like is better really depends on your use case. They definitely have different performance characteristics. Okay, I wanted to look up the multi-map because it actually has a multi-map. It has a very specific method to actually get the elements. Yeah, okay, equal range. Okay, so we just get two iterators. That's our begin and end. Okay. Sure. So then what I want to do is if weak else, because these two things will be different. But this will be always the same. So this will be std pair of std unordered multimap of unsigned iterator, I guess const iterator. Okay, so pair of these will be our range, right? And then what we do here is range equals, for the week, we want to go to g.weeklinks.equalRange node. And here we want to go range equals g.stronglings.equalRange node. Right. Okay, everything is okay. And now we just want to go over all of them. So for range dot author I equals range dot first, I is not range dot second, I plus plus. So just iterate over all the elements of this range. And what we want to do in each of those cases is path.pushback path.pushback. So okay, this iterator is yeah, so this is the iterator inside into the map. So in this case, we want the i.second, which is the end of the edge. So we want to add this, not actually directly like this. So first of all, we want to check if this is already in the path. So for path, let's just go over the path. Okay. And then there'll be something here. So if j equals i.second, so this element is already in the path, then we just do front equals true. Okay. No member second in node const iterator false false. Okay, I think there's some sort of mismatch of things happening. Okay, let's roll back a little bit. So this thing is value type what? Const iterator, legacy bidirectional iterator. I mean, that's const key. That's all making sense. What's the trouble here? I mean, first second should be just unsigned. Wait a second, what is J? J should be just an unsigned number, right? Oh, but because this is iterate, yeah, okay. It should be like this. Because it's an iterator, yes. Okay, so if we have found it, then we just skip over this element because it's already in the path. Otherwise, we push it onto the path and we call this function again with the length remains the length, that's fine. The function remains the same. Path remains the path. But the thing that changes is whether we are looking at a weak link or strong link, so not weak. And once I have done that, what I want to do is actually path pop back to remove it out of the path. Right. I think that kind of looks like it works. So this is our terminal case if we have the path of the specified length, and by the construction of the path we know that the strong and weak links are interleaving in the correct ordering also. We just call this callback that will ensure that the things get removed out of the Sudoku puzzle. Then we get the last node of the path. We get the edges coming out of this node. And then for all the edges coming out of this node, we try to basically recursively extend the path. Okay, no, that should work. So then, because this is kind of expecting that there's at least one thing in the path in here. So what I need to do in here is I basically do path pushback. So basically for all the possible starts of this chain, and I call this function, the first link needs to be strong. So this will be traverse with the graph, with the length, with the function, and this needs to be false. So weak is false, which means we are looking only at the strong links, which is this branch. Okay. Graph length. Oh, and the path, right. Okay. So what I now need to write is the actual function that will look into the puzzle and try to figure out if there's something to remove. So okay, I get the graph. Then at some point I will just do the DFS traverse for this graph for the length, right? Yes. And yes, I will have the function in here. As a lambda. So with this callback, and that's it, right? Okay, so what will this thing do? That's the important question. What are you complaining about? No, okay, now it's fine. So I will need to write a new functionality because I don't have. Basically, what I want is get or either get a list of nodes seen from 2 offsets basically, or alternatively for all nodes, well, not nodes, no, I'm talking about the puzzle. So for all squares seen from 2 offsets, prune a number, right? So I basically need one of these 2 methods on my Sudoku puzzle. I think the second one will be more convenient. So that basically means I need to capture this, and I need to capture the number. So this will be offset 1, offset 2. And I will need some sort of method that will be prune numbers seen from of 1 of 2 number, something like this. Okay, so how will this method look like? Yeah, writing this will be not easy because I don't think I have like a convenient way to determine that something can be seen from 2 places. Okay. And why does it not copy the parameters? That's so weird. Okay. So let's go back to the... So what exactly does that mean? I basically want to get all the blocks for this square, get all the blocks for this square, and figure out the squares that belong to to an intersection of those 2 things. Yeah, basically get me all the squares. Oops. Yeah. Ah, damn it. Okay. So get me all the squares this thing can see, and get me all the squares this thing can see. And then the intersection is what I care about. And in this case, I would be like removing the 5 from these squares. Okay. Yeah, I don't really have a good way to do this, so I think I will just need to brute force it basically. Just get all the squares and get all the squares get all the squares on either side, and then just make the intersection done. Yeah. Okay, but I also need to be careful because we run into this already. So if let's just get rid of this. right? So if I would have this kind of situation, right? And this would be the ends of the chain. The intersection now is this entire row. Oops. And that's it. But these two numbers, like these two offsets, need to be excluded out of that. And actually, what? Oh, you mean nerd stuff, not neat stuff. I was like, what is neat stuff? Yeah. Well, you know, what can I say? I don't really have, you know, like a great reasons to watch me, you know, so. But I definitely appreciate. Right. What I'm thinking about right now is if I go back to this, the tricky part is I think we need to exclude like all the elements on the chain, because well, I mean, that's still a valid question. Like, if you are a programmer, then why the heck are you watching, like, you know, coding stuff over the weekend as well? That's not an invalid question, just FYI. Okay. Can I find in these examples like a case? Yeah, okay, so in this case, like, there's a bunch of, like, we are removing a lot of different things, but we definitely cannot remove any of the elements that are actually on the path that we have just found. So this is actually trickier. Shoot, okay. Yes, definitely learning never ends. I totally agree with that. That basically means I need to pass the path into this callback. But I guess that's not. That's actually okay, because like what I have in the path are the offsets. I can just filter by that. Okay. So it's slightly more complicated, but it's not crazy. So the only thing that happens here is that I also get the path, right? And then this thing over here needs to also take this. And I guess this thing over here as well. Yep. And when I call this function, I also give it well, let's just do this. It makes everything a little bit simpler, considering I look at the beginning and end of the path. I might as well just like pass the path and then be done with that. Yeah, okay. I always like overcomplicate things. Right, so this just gets this. So here we just pass in the path and the number, yes. So this needs to look slightly differently then. So this needs to take the vector. Okay. Okay. So what I'm interested in is the beginning is path 0, then and is path size -1. I'll just call it begin so it's not so long. Okay, so how do I get... Well, I have a function get... no. Block mapping. Okay, so this tells me what are the blocks at the given coordinate. So basically what I want to get is block mapping begin divided by size, because these are offsets, and then begin modulo size. So this will be blocks at the begin. And this will be the blocks at the end. Right. Well, so now we have all the blocks. Now from the blocks I need to figure out what are the squares that are inside of these blocks. So for that, I think I will just use another set of square star. So this will be the squares belonging to the begin, and this will be the squares belonging to the end. Actually, I can do it slightly smarter. Okay, so blocks squares belonging to the begin will be right. So this should be a not a square, a block checker. Yes, a block checker. No, that makes sense. Get yeah, okay. Well, I just need to, I guess, iterate over all the positions of squares inside of the block and do bs insert s get square I. Okay. So just go over all the blocks belonging to the begin square or I mean the other way around, like all the blocks that contain the begin square, because that's the relationship, it's not the other way around, and just insert all these squares into BS. But actually what you want to do here is bool skip equals false for auto j path if j so okay, so j is an absolute offset, I is a relative offset inside of this block. So what I want to compare is data j equals s get square I. Then we want to skip over the thing because it's part of the path. So if skip, then just continue. Oh, come on. Otherwise, put it into the set. Right. No? What? Ah, yes, okay. I'm comparing. I need to compare this wasn't the pointer. Okay. Okay, now it should be fine. So now I have all the squares that can be seen from the beginning of the path that are not part of the path inside of here. So now I kind of want to do the same thing for the end, but I don't really need to do an intersection. I just can like look up if this is actually a square I care about, and this we need to do exactly the same. But here, instead of inserting or doing anything, is I want to do bs find. I want to find I want to find the square. And if the square can be seen from both of the ends of the path, then what I want to do is get square I well, okay, remove the number from the square. Okay, that should be fine. So we have the beginning of the path, end of the path. We get all the blocks that contain the beginning of the path, all the blocks that contain the end of the path. We go over all the blocks that contain the beginning of the path and insert all squares from those blocks into a set, but only those that are not part of the path. So it will skip over the beginning, end, and everything in between. Then I go over all the blocks that contain the end of the path, and for each of the squares inside of those blocks, I check if that square is also part of the squares that belong to the beginning blocks. I don't even know anymore what I'm saying, but hopefully it's understandable. and this I guess, no, this is correct. Okay, beginnings, yeah, okay, so I look into the BS, which is the beginning squares, and if it's not, if the square is there, then it's seen from both the beginning and end of the path, and I remove the number from it. Jeez, okay. I need a 5-minute break. I will be right back. Okay, I am back. Right, so what we need to do now, I guess, is actually write some tests to see if this actually works. Well, let's just verify this method itself works, because that I can do separately. Okay. Okay, just click like this. I don't really need any text for this. Right. So we want to construct a Sudoku. I guess I could just copy paste something like this, that's fine. Okay. Right. So this just removes 8s from all the places in the puzzle. So I just want to strategically add them into specific places, right? So, okay, let's just draw it up. So what do I actually want to do? So let's say I just create a path that will be something like this. Yeah, okay, so let's say the path will be like 1, 2, 3, 4. Not that it makes any sense. But just to basically double check if things are actually working, right? So then what if I put an 8 here, 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 and here, the 8s that I want to remove are these ones. Because this is the beginning of the path, this is the end of the path, so the intersection will be this column, and then I don't want to remove any of these 3, and obviously not this one, but this one should not even come into consideration, essentially. Okay, so the places I want to I guess I can make it as a loop. So basically I want to add the column I1. So the second column will get the 8s back, and then I basically want to insert an extra one, which will be row 1, column what is it, 876, right? Okay, so this can go away. Then what I expect to happen is that this one will also be in the result, and apart from this one, I also expect to see 1, 1, so 8, 1, and so this is 8, 7, 6, 5, right? So 5, 1. Okay, so the input is just the entire column plus the 1 extra, and then these 4 should remain in the puzzle. Then I need to craft my path, so the path will be vector unsigned path. So okay, so the path is 8, 1, so 8 times 9 plus 1, then 1, 8, and 6, okay, so 1, 6, I guess I can just, yeah, have the numbers here. Path, the third one is the 5, 1, plus 1, and the last one is the 1, 1, so this will be on times 9 plus 1. And then if I do puzzle, not puzzle, test, test.prune numbers seen from, path and the number is 8, then what I expect is that I already have this check a bunch of places here. So what I expect is that the test equals expect at every position in the puzzle. Right. So this is the Sudoku tests. Let's run it. And it seems to work. Okay, so let me just break it somehow. So if I, well, okay, if I just remove one of these expectations, that should fail. And it does. Okay. Yep. Cool. Now this is very cool. This seems to be working, which I'm shocked by, honestly, because that usually doesn't happen on the first try. So since this thing works, let's see if the actual chain generation nonsense works. So for that, what I actually want to do, I want to copy some of the examples. So test case Sudoku solve chain test. Okay, so let's try to copy the examples. Not those, these two. Okay. So since we are only affecting a single number, I don't really need to copy the rest of the puzzle. I just need to copy the positions of the 7 in this puzzle and the positions of the 3 in this puzzle. And in this case, we are looking for a chain of size 6. In this case, we are looking for a chain of size 1, 3, 4. Yes. 1, 2, 3, 4, 5. No, this is 6. This is 1, 2, 3, 4, 5. Oh, both of those are 6. What the heck? Is there a chain for somewhere? Probably isn't in here, but there could be one elsewhere. Well, okay, let's just test the chains of size 6 then for now. Okay, so 2 puzzles. In one we are removing the 3s, in one we are removing the 7s. So let's just make 2 different tests for this. Okay. So let's just grab Notepad for a bit and let's just write this down. So in row 0 we have position 1 and 8. In row 1 we have positions 0, 1, 7, 8. In my phone keeps going crazy for absolutely no reason. In this row, oh, okay, so there's a 7 set here. Actually, that's interesting. That's important. Yes, because one thing I didn't actually realize is I don't want to ever look at spaces that have a number set, so that's a thing I will have to fix. I don't think it actually breaks anything in particular, but I think it's just pointless at looking at numbers that are already set, because for those we have already applied the other pruning techniques that basically got rid of the potential candidates, and it just makes everything more complicated, computationally wise, I mean. So this is 0, 1, 2, 3, 4. On the row 3 we are at 0, 1, 2. That's it. Row 4 we have a set 7 at position 3. Then at row 5 we have a set 7 at position 6. Then at row 6 we have a 0, a 2, a 7 and an 8. Then row 7 it's 0, 1 and an 8. And at the last row we have a set 7 at position 5. Okay. And so test 0, 1, 7, 0, 8, then 1, 0, 1, 1, 1, 7, 1, 8, oops, then 2, 4, 3, oops, 0, 3, 1, 3, 2, 4, 3, 5, 6, and 6, 0, 2, 7 and an 8. Okay, then here a 7, 0, 7, 1 and a 7, 8. And an 8, 5, right. Okay. And what do we expect to happen again? We expect the 0, 1, 2, 3, 3, 1 to get removed, right? So the expect will be exactly the same. Is it called yeah, expect. Okay, so just edit, find, replace test by expect, replace all, and the what was it again? The free one should be gone. Okay, and let's just do our check. But this will not be prune. This will be the solve X chains for length 6 for the number 7. And we expect that this happens. Okay. Let's run it. Oh, wow. Okay, like I'm seriously disbelieving that this is actually working on the first attempt. But it seems to, what the heck? I somehow managed to not make a mistake? That's crazy. Well, okay, let's just try the other test as well. Then I just need to fix up the don't look at the fixed numbers situation, but other than that we are golden, I guess. So here, okay, I need my notepad again. Thanks. I mean, to be brutally honest, like most of my streams were just like 3 hours of debugging like a tiny bug in my code. That's basically like 50% of my streams. So I am genuinely surprised. It's not hyperbole, like it's definitely a little bit weird. Okay, so the first row has the 3 at position 3. S is at position 6. Then this one is position 1, 2. The third one is 1 and 7. Fourth one is 5, 7, 8. Then row 5 is 0, 1, 2, 3, 4, and 8. Okay. Then this one 6 is position 4, 5, and 8. Then 7 is 0, 1, 2, 5, 7. Okay. 8. So this is position 0, 2, 3, 4, 5, and that's it. Okay. So let's just quickly rewrite this into here. I should rewrite some sort of macro for this. If I knew how to do that. But I don't. Nah, this probably doesn't help, actually. Okay, oops. So then 1, 6, then 2, 1, 2, 2, 3, 1, 3, 7, 4, 5, 4, 7, 4, 8. Okay, then 5, 0, 5, 1, 5, 2, 5, 4, and 5, 8, and 6, 4, 6, 5, 6, 8, 7, 0, 1, 2, 2, 5, and 7, and the last row was okay. 0. At some point I will really get bored with this and write some convenience things for doing this easier, but I'm actually not sure like how would I do this better. I mean, I guess the easiest way would be just like to visually like set it up just in a UI and then just run the tests on that. But meh. UI is definitely coming at some point, just not yet. Okay, again replace all, right. Then the threes we want to get rid of are the ones in 0, 1, 2, 3, 4, 5. and these three. Okay. And then I just copy this part. We want to solve chains of size 6 for the number 3. Let's see. Wow, still working. Okay, I guess I just managed to write this correctly. Cool. So in that case, I'm very much interested what this will do to my solving strength. So now I need to go to the Smart Solver. And now the interesting part is to figure out where to actually put this. So I'm trying to organize the methods by like how complicated they are. Yeah, like chains of size 4, I think. This is tricky. I don't know. I think chains of size 4 I would put here between the size 5 and size 6 fish. Yeah, okay, let's do it. So first thing of all, we need to go over all the numbers the same way as for the fish, because these rules are always number specific. So what we want to do is Sudoku solve x chains for length 4 and the number j. And then this just gets copied, except in the stats we actually need a new thing. So this will be x chains size 4. Okay. And that thing is in solve stats. Chains, and we need to modify the way we print it. So fish rules, find fish rules. So we start at 4, we go up to that's another good question, like how long of chains we want to do. Let's say we go up to 12 for now. But we don't want to do plus plus, we want to actually do plus equals 2, because the chain always needs to be even length. And then what we do is if stats.xchains.find I is not stats.xchains.find not find. I'm so happy that in C++20 they added contains, because this code is so annoying. Right. So if this is the first thing we are printing, then what we do, we print a header. Exchange rules. Oh, come on. Stop mistyping things. And then stats.exchange.find I as exchange of size I. and yeah, okay, that should be. What's wrong here? Add. Okay, that looks correct. Okay, no, it's fine. So chains of size 6. I think, yeah, let's just slot it after the fishes of size 6. That might not be correct. Okay, and then what I will do, I will just do chains of size 8 will go here after the finned fishes of size 5. Well, okay, maybe actually, okay, this is just like brutal guesswork. I will need to at some point look up, because there are some websites that actually like have complexity ratings for like different solving methods. And yeah, let's just put the 12 to the very end. And then I can just resort this based on, you know, that, because that's more meaningful. I guess that should actually work, I hope. Okay, so let's switch to the terminal. Oh no. Okay, so let's just try the first 1000 puzzles. And let's see if anything explodes. Yeah, there's something exploding. Oh no, what the heck? That's wrong. What the heck just happened? Am I running the wrong binary? Maybe I am. Ah, okay, good. So first 1000 puzzles. There's nothing. Okay. First 10,000. Still nothing. But we didn't really improve our solving technique either. Okay, maybe the exchanges themselves are not enough. What the heck? This is not doing anything. Like, if this doesn't trigger at all, there's something wrong somewhere. And I need to add some sort of progress bar to this. Okay, this is taking weirdly long now, which makes me suspicious. Because this is basically 10 times the previous data set. Million puzzles instead of 100,000. And I'm pretty sure the 100,000 finish pretty quickly. Okay, let's just check the code. Oh, okay, it finished. But we still have 0 cases where the chains actually applied. Okay, what I will do, I will just take this one and just put it like high up, so it actually gets triggered very early. So hidden groups, solve, yeah, sure. Block intersections. Let's do it. Yeah, here. Oh, what the heck? And wait a second. So, I mean, this is saying that the correct binary is actually in here. No, but these haven't been updated in ages. So, what the heck are you on about? Yeah, I mean, that's today, right? Yes. Okay, I don't know. That output is weird. Okay, well, let's no, million is too much. So let's do it like this. Let's see if it gets triggered if I put it like very early on. Still nothing. That's weird. Am I just like printing it wrong or something? So I go for the sizes, chains at I find it extremely suspicious that it never triggers. I mean, it is possible, but I find that super unlikely. And the weirdest part is like, it did work in the tests, so Okay, let's just put it. Oops, no. I don't want to put it before groups of size 2, do I? Maybe I do actually. I want to see it trigger at least once. Yeah, by putting it so early, I'm just making my solver super slow. And it still doesn't trigger like at all. What the heck? Okay, you know what? Let's just go the crazy way. So let's just pre-solve everything. Okay, so this should really try like all the chains at the very beginning. Maybe I don't need this continue actually. Okay. Like if this doesn't trigger anywhere, it's really strange. There should definitely be puzzles. What the heck? Well, as I said, debugging weird bugs. I'm like confident this is a bug somewhere, because I don't think this is possible. Indeed, like it was too good to be true for sure. What the heck? Okay, let's just do a sanity check here. I mean, just to make sure that I'm just to make sure that I'm actually not just what the heck? So it's a printing pack? How is that possible? Okay, let's okay, so somehow this doesn't get printed. How the heck is that possible? I try to find the size. If I find it, okay, let's ignore the header for now. Chains at I. What the heck? Okay, let's. This is super confusing. Yeah, I mean, okay, mostly it's actually just zeros, but there were definitely some ones in there. Okay, then maybe just revert back to the code I had before. Size 6. Size 8. Oh, I know what's the bug. Damn it, I'm such a moron. Yeah, I just realized it because I was like, how the heck does it go down from 1 back to 0 when I'm not resetting it? But the problem is I'm actually resetting it. It's just that... damn it. Okay, I want to put it here. Where was the place where it was supposed to be? Fish size. Oh yeah, so here. So the bug is that what I do, I actually take the stats from solving one puzzle and I just add them to the global stats. But of course, since I just added a new field, I need to extend that method as well. Silly bugs. Always it's something stupid. It's like whenever I'm debugging something at work and I kind of like am completely confused at what the heck could this be, like after 20 minutes I always ask someone else because usually it's something completely stupid. Right, so where the heck do I do this thing? Yes, okay. Oops. Okay. Stats exchange, yes. Okay. Now we should see something happening. Wait, did it not rebuild? What the heck? Why is this still printing stuff? rebuild. Proper rebuild. Okay, now it's working. Okay, this was the 100,000. Good. Okay, it's happening. Perfect. But I'm not sure if this actually helped us to solve some puzzles. I guess that's easy to see. So if I okay, exchange. So let's just quickly comment this out and let's store this result. Just to quickly compare what's the strength of the solver before and after. Okay. Okay. So that's 12, 10, 8, yes, okay, so I have all of them. So let's just rebuild again and see what's the result. So, okay, so it's very slightly better. So we managed to solve an extra 159 puzzles out of 100,000. That's like what? So, okay, let's just do it properly. So 98965 minus 98806 divided by 100,000 times 100 is like 0.15%. Okay, let's round up the correct way. So 0.16%. Holy crap. Okay, I was hoping this would be so much better than that. Well, the good news is it works, and the second news is this was just one type of chain, and with the same logic I can kind of build the other chains as well. Okay, although this one is a little bit trickier to implement because this is like arbitrary values that kind of chain against each other. Yeah, I mean, we will need to implement some of these more crazy rules, I guess. Ah, damn it. Like the search algorithms will be very similar for these, but I guess the data structures will look slightly different. Okay, nice loops. So here we ignore what's inside of the squares. Okay, so this is actually operating on a graph across all the numbers, and then we basically count the number of links that a particular square has. Okay, but only if there is actually a loop. Okay. Yes, so we basically find loops and then do this logic on top of that. Okay, let's see it. So we have a loop here, right? What the heck? Okay. Okay, so this is this one. When a node has two different links, one weak, one strong, the digits must be the same. And because this one has one weak link with the 7 here and one strong link with the 5 here, that's wrong. Okay, because these have all the other places on the loop have weak links with different numbers. So this one has an 8 and a 4, which is allowed. When a node has two weak links, the cell must be by value and the digits must be different. Okay. So okay, in this loop, if the node has two strong links, the digits must be different. Okay, so with this node, that's fine. It has a 4 and a 2. But then this one has a 4 and a 4, which breaks because now it's the same. Okay, so the loop starts with a strong link on 4 premise if R8C2. So R8C2 is this one. Is not 4 and it ends on a strong link on a 4 as well, yes. Yeah, okay, so if we have the same number, I think this I can implement reasonably easily in my solver. Okay, so here's another example, right? So this node has two different strong links. It has a 7 link and a 9 link. And what this said is when a node has two different links, one weak and one when a node has two strong links, the digits must be different. But that's okay. Why are we then removing these two, the 8 and a 4? That I don't get actually. Okay, I think I will need to look at this tomorrow, because even considering the technical issues at the beginning of the first attempt of streaming today, I have been streaming for a while, and I think my voice is slowly dying. But I mean, the situation improved, but it improved very marginally. Let's just say that. I have to conclude that, unfortunately, the improvement is very marginal. Before I go, I actually want to try one crazy thing. So, technically, our solver isn't really constrained by the length of the chains. So, what I can really do is in here just do 12 size less than equals 24 size plus equals 2 yeah, I can basically try like crazy big chains. And let's just return this back. To see if it has any impact. I don't really expect this to have an impact, because honestly the short chains should be very much enough. First of all, I also want to save this. Okay, and yeah, let's just build it and let's try it. Oh, I need to also where the heck is it? Solve stats, yes. Now we are going up to 24, and in the plus operator that one doesn't care about the limit. Okay, so let's try again. Again, I don't really expect this to be better. It would be actually pretty weird if it was better. But I have been surprised before, so who knows? Yeah, no, there's just chains of size 4 and 6, like we are not finding anything bigger at all. Right. I will leave the other chains for tomorrow then. So, if you don't know, I stream every weekend starting at 2:30 Central European time, unless I have technical issues like today, and then weird things happen, but hopefully I still don't know what that was, but anyway, I will be streaming tomorrow again starting 2:30 Central European time, and then going until my voice dies again, I guess. If you have any questions, if you think about any questions, if you're watching the recording, feel free to leave comments on the YouTube video. Otherwise, catch me up on some future stream, and I will be super happy to answer any questions. or ping me on GitHub, because this code is all on GitHub. See you later.